Battery swapping stations for electric vehicles are rapidly emerging as one of the fastest ways to refuel an EV, reducing charging time from hours to just minutes and offering unmatched convenience for drivers. These automated facilities allow a car to drive in and exchange its depleted battery for a fully charged one in roughly 3 to 5 minutes, a process often faster than filling a gasoline tank and far quicker than even the fastest plug-in charging. Using robotics, sensors, and cloud-connected systems, the stations lift the vehicle, remove the old pack, and install a fresh battery without the driver leaving the seat. Industry leaders have already deployed thousands of these stations worldwide. Companies like NIO operate more than 2,200 locations, completing millions of battery swaps to date. A typical station stores multiple fully charged batteries and can handle over 300 swaps per day, proving the model is scalable across dense urban areas and highway networks. Battery-as-a-service programs further reduce the upfront cost of EV ownership by allowing drivers to lease battery packs, while centralized station charging helps balance power grid demand during off-peak hours. Tazari 04 Buggy is an electric off-road adventure vehicle built for fun, rugged terrain, and coastal cruising, combining eco-friendly performance with everyday usability. As a 4-seat L7 quadricycle, it balances compact size, smart electric propulsion, and leisure-oriented capability, standing out among typical off-road buggies. The buggy is powered by an electric motor rated at 15 kilowatts continuous and up to 25 kilowatts peak, propelling it to a top speed of 56 miles per hour. Equipped with a 14 kilowatt-hour lithium big battery pack, it can cover roughly 112 miles on a single charge, enabling extended off-road exploration without frequent recharging. The lightweight lithium LFP battery supports up to 3,000 charging cycles, managed by a sophisticated battery system that optimizes energy use and offers 3 driving modes: Eco, Drive, and Sport, to suit terrain and rider preference. Energy is further recovered through its electric brake system, and the onboard multi-power charger works with standard household outlets. Designed for sun-soaked adventures, the 04 Buggy features a rugged yet stylish body, practical cargo space expandable to 750 liters, full LED lighting, a digital touchscreen dashboard, 4 disc brakes, and all-season tires. Sidos Euromotion flying car you're referring to matches the concept now best known in the aviation world as the AutoGyro Gyrootion, a hybrid autogyro built to operate both in the air and on roads, and currently certified for use in the Czech Republic under its local aviation and road regulations. This machine blends an aircraft's flight capability with everyday ground driving, bringing the dream of a real flying car closer to reality. Its design uses a rotor in auto-rotation for lift and a conventional engine for forward thrust, letting the pilot take off from a runway, soar through the sky, and then switch to road mode for ground travel on familiar streets. Gyrootion has a maximum flying range of about 373 miles and cruises close to 115 miles per hour in the air, with a top speed near 120 miles per hour, moving significantly faster than most personal aircraft of its class. Empty weight sits around 540 to 650 pounds with a maximum takeoff mass near 1,232 pounds, powered by reliable Rotax engines that balance performance with efficiency. It also supports a ground driving range of roughly 30 miles and a limited road speed when operating in driving mode, giving it true dual-purpose capability. By proving this hybrid concept in real certified operations in the Czech Republic, Gyrootion shows how flying cars can transition from concept to practical machines that navigate both sky and street with autonomy and real-world performance. Wave Engine Pulsejet Engine for UAVs is a revolutionary propulsion system that adapts the simplicity of classic pulsejets for modern unmanned aviation, delivering verified, real-world performance. Developed by Wave Engine Corporation in Baltimore, Maryland, this engine generates thrust without any moving mechanical parts by using pressure waves produced through intermittent combustion inside a hollow tube. Instead of turbines or compressors, rapid pressure pulses push hot gases out and draw fresh air in, producing continuous thrust with far fewer components, and significantly less complexity than conventional jet engines. The first production model, the J1 Wave engine, is built for high-speed UAVs with gross weights up to 200 pounds, producing up to 53 pounds of thrust, enough to power takeoff, cruise, and landing using this pulsejet cycle. The engine weighs about 18 pounds, measures 5.5 inches wide, 5 inches tall, and 64 inches long, and runs on common fuels such as gasoline, bioethanol like E85, or kerosene-based jet fuels including Jet A and JP8. A key innovation is its digital engine control unit, which manages fuel delivery and ignition timing, allowing instant starts and even mid-flight restarts. Wave Engine's technology has already been demonstrated in UAV test flights, showing smooth transitions from takeoff to cruise and reliable in-air engine restarts, proving its viability for next-generation unmanned aircraft propulsion. AI programs for playing Go, most notably AlphaGo, developed by DeepMind, mark a breakthrough in artificial intelligence by mastering one of the most strategically complex board games in existence. Go's vast number of possible positions, far exceeding the number of atoms in the observable universe, made it a long-standing benchmark for testing AI's capacity for intuition and long-term strategy. AlphaGo combines deep neural networks with reinforcement learning, enabling it to learn from millions of human games while also improving by playing against itself, continuously refining its decision-making without human intervention. In historic matches, AlphaGo defeated top-ranked human champions, including Lee Sedol and KG, demonstrating the ability to plan moves far ahead, anticipate opponent strategies, and execute creative plays that even experts found surprising and brilliant. The same AI techniques have since been applied to other complex domains, from protein folding and logistics optimization to robotics, showing that machine learning can tackle problems once thought to require uniquely human intuition. These programs underscore not only raw computational power, but also AI's capacity to integrate pattern recognition, prediction, and adaptive learning to surpass human performance in highly intricate decision-making environments. Jet Capsule is a futuristic Italian-designed watercraft that redefines personal and commercial travel on water with style, performance, and versatility. Developed by Lazzarini Design Studio, this compact vessel combines advanced hydrojet propulsion with engines producing between 370 and 740 horsepower, enabling cruising speeds of around 40 miles per hour while delivering agile, responsive handling that sets it apart from traditional boats. Its carbon-reinforced hull and photochromic windows, glass that adjusts tint with sunlight, provide a sleek, lightweight, and durable structure with a striking, spaceship-like appearance. The Jet Capsule offers highly customizable interiors for leisure, water taxi service, or modular layouts such as lounges, sleeping areas, and galley kitchens, comfortably accommodating up to 10 passengers plus a pilot. Optimized hull geometry enhances stability and efficiency, while the hydrojet system ensures precise maneuverability in varied water conditions. With its combination of speed, luxury, and adaptable design, the Jet Capsule delivers a modern, high-performance boating experience ideal for coastal cruising, island hopping, private tours, or upscale water transport. Enhanced mobility exoskeletons emerging in 2026 are making advanced movement support more practical and accessible for everyday life. These wearable robotic systems reduce physical strain, increase endurance, and help users walk farther with less fatigue by augmenting natural motion with lightweight motors and intelligent sensors. A notable example, the Hypershell X exoskeleton can offset up to 66 pounds of effective load, cut physical exertion by around 30%, and extend walking range, allowing users to cover longer distances with less effort and reduced muscle strain. Unlike bulky industrial or medical rigs, these mobility exoskeletons weigh only a few pounds and fit comfortably on hips and legs, making them suitable for outdoor exploration, travel, daily walking, or physically demanding tasks. Compact rechargeable batteries and adaptive control systems sense movement intent in real time, delivering assistance that feels intuitive rather than cumbersome. By combining practical design with tangible performance benefits, Modern enhanced mobility exoskeletons are helping people stay active longer, work more efficiently, and push the boundaries of human capability in everyday environments. Roboa snake-shaped rescue robot is a soft, pneumatic robotic system engineered at ETH Zurich's Autonomous Systems Lab to reach places humans, drones, and most machines simply cannot. Instead of wheels or legs, Roboa grows forward like a vine by eviting a flexible fabric tube using compressed air, letting it slither into narrow pipes, collapsed buildings, sewers, and tight gaps as small as 2 to 4 inches in diameter with ease. Its unique locomotion reduces friction and avoids the need for traction, making it safe to operate on dusty, wet, or slippery surfaces without getting stuck or causing sparks in hazardous environments. The current prototype can extend up to about 328 feet in length while remaining pliable and maneuverable, and its modular design supports 3-dimensional steering throughout that reach. Onboard sensors, including cameras and time-of-flight systems, stream real-time data back to operators, while a built-in speaker and microphone allow rescuers to communicate directly with trapped victims. A supply line integrated into the robot lets responders deliver essentials like water, food, or medicine deep into blocked spaces during critical missions. Controlled remotely through an intuitive operator interface, Roboa combines advanced sensing, adaptable motion, and direct communication tools to transform how search and rescue and industrial inspections approach otherwise inaccessible environments. The Hogwarter Pro chainsaw is a heavy-duty woodcutting tool built for powerful performance and rugged outdoor work. Equipped with an 18-inch cutting bar and chain, it delivers deep, efficient cuts through logs, fallen trees, and thick branches with professional-level capability. Unlike standard homeowner models, the Pro's high-displacement engine churns out strong torque that keeps the chain driving aggressively through dense wood with minimal stalling. Its cutting assembly spins at speeds upward of 8,500 revolutions per minute at engine peak, giving it the rapid chain motion needed to slice cleanly and quickly through tough material, which is on par with high-performance chainsaws used in forestry and heavy landscape work. The powerful engine backing this system produces robust output, far more than the small 42cc models you find on everyday yard tools, delivering consistent, reliable evasion of kickback, while the advanced chain brake and ergonomic handle help maintain control and safety in demanding use. Built-in vibration reduction systems and automatic chain lubrication keep the operator comfortable during long cutting sessions and make maintenance easier, letting you focus on performance instead of fatigue. By combining its sturdy 18-inch guide bar, rapid chain speed, and a strong gas engine, this chainsaw stands out as a professional-grade tool ready for forestry tasks, storm cleanup, and heavy outdoor projects that require dependable cutting power and durability. Floating wind turbine initiative in Spain is part of a growing wave of offshore renewable energy that aims to unlock wind power far out at sea, where deep waters make traditional fixed-bottom turbines impractical. Spanish companies, including Sena Renewable Investments and the AMPA Group, are working on semi-submersible floating platforms that can support turbines rated at 15 megawatts or more, using advanced steel structures tested in wave tanks to ensure stability and performance in offshore conditions. These scalable floating designs are intended to lower costs and expand wind energy potential by allowing massive turbines to operate in deeper water zones, where wind resources are stronger and more consistent. In parallel, large projects such as Capital Energy's planned Breogán floating wind farm off the coast of Galicia will feature dozens of floating turbines, each with 15 megawatt capacity, contributing hundreds of megawatts of clean power to Spain's grid and marking a major investment in renewable infrastructure. These developments are supported by significant public and private funding as part of Spain's broader strategy to build gigawatts of floating offshore wind by 2030 and drive the transition to low-carbon energy. As we wrap up, these life-changing innovations aren't just cool concepts. They're the technologies that will redefine our daily routines, elevate human capabilities, and make the future more connected, efficient, and exciting than ever before. Whether it is smarter transport, groundbreaking robotics, or futuristic gadgets, one thing is clear. The world is evolving at a pace that demands we pay attention, adapt, and embrace the extraordinary. If today's breakthroughs have amazed you, just imagine what is coming next, and make sure you are ready to experience it firsthand. If you enjoyed this deep dive into the future, go ahead and like the video, share it with someone who loves innovation, and subscribe for more next-level content.